Hello children, welcome back to the digital class. I hope you are all doing well and you might all be excited to learn some new and interesting concepts in our today's mathematics session. So children, let us start our session. So today our topic is operations on integers. So before exactly going to that, children, let us quickly recall what we have learned in our previous sessions. Children, take a look at the numbers shown on your screen 1, 2, 3, 4, 5, 6, 7 and so on. Children, do you know what these numbers are called as? Absolutely right children, they are called natural numbers or even we call it as counting numbers. Now take a look at the numbers shown on your screen now. Yes. Do you know again what these numbers are called? You are right once again children, they are negative numbers. Now children, do you find any number which is neither positive nor negative? Yes, that's right, it is a 0. So 0 is neither positive nor negative. So children, let us see what these numbers are called as. So integers, the collection of positive numbers 0 and negative numbers is called integers, and we write it as z is equal to, you can see a floor brackets, in between that we are writing these numbers, that is 0, 1, 2, 3, 4 and so on, minus 1, minus 2, minus 3, minus 4 and so on. So children, these numbers, that is 1, 2, 3, 4 are positive numbers, and in the center, that is we have exactly 0 which is neither positive nor negative, and towards left side of this 0 we have negative numbers. And children, make a note that the set of integers is denoted by letter Z, that is a capital letter children. Okay. By the end of this session you will learn addition of integers, subtraction of integers, and also will learn properties of integers, and in these properties we are going to learn about closure property, commutative property, associative property, additive identity and also additive inverse. So these are the properties that we are going to learn in our today's session children. So let us start with addition children. So children, what do you notice on your screen? That's right, it's a integer number line. Okay children. So we have 0 here which is neither positive or negative, and towards it right if you see, we see all these positive numbers, isn't it children? Now again if you notice towards its left side you see all the negative numbers. So numbers to the left side of 0 are always negative and the numbers to the right side of 0 are always positive. So children, let us consider a red coin which is equal to +1, okay children, and that is nothing but a positive number, and a green coin which we denote it as -1, that means it represents a negative number, and we have a pair of both red and green coin and we mark it as 0. A 0 pair represents one positive and one negative number, that is +1 plus of -1 is always equal to 0. Okay children, so that's we call it as a 0 pair. Now let us learn about addition of these integers. So let us take a first example. We are going to add 5 and 4, and notice children here 5 and 4 both are positive integers. Now 5 plus 4. Now since we have +5, it is denoted by 5 red coins, isn't it children? Then similarly we have +4, again it is a positive integer. So what do we represent children? Yes, we represent it as 4 red coins. Now together let us see what we are going to get. So we have taken these 5 coins and then 6, 7, 8 and 9. So altogether how many coins are there children now? That's absolutely right, we have 9 red coins which represents +9. That means on adding 5 and 4, that is 5 plus 4 is 9, And children, notice that when we added two positive integers, what did you get, children? Yes, 9, which is a positive integer. On adding two positive integers, we got a positive integer. Now, let us take another example, children. I am going to add -5 and -4. So, -5 means 5 green coins. Similarly, -4 means we have 4 green coins. Now, let us add them, children. So, on adding these, what do we get? So, first we have -5, so that means 5 coins. Then we have 4 green coins, and together count, children, how many we have? Yes, you are absolutely right. We have 9 green coins, and green represents, yes, a negative number. That means we have -9. So, -5 plus -4 is always equal to -9. And children, what do you notice here? Yes, on adding two negative numbers or negative integers, you got a negative integer. So, what do you conclude, children, from these two examples that we have learnt? The sum of two positive integers is always a positive integer. Similarly, the sum of two negative integers is always a negative integer. So, let us take few more examples, children. Now, I am going to add -5 and 4. That means a negative number and a positive number. So, let us add these two, children. So, -5 means it represents 5 green coins, and +4 means 4 red coins. Now, let us add them, children, now. So, here we have 5, okay, that is green, and we are going to place these 4 red coins just below the green coins. And what do you notice, children, here? Yes, I am going to get a 0 pair over here. Okay, how many 0 pairs are there like that? We have 1, then 2, 3 and 4. So, we have 4 0 pairs. That means what actually its value is? Yes, it is 0, 0, like that you got all these 4 0 pairs. Now, out of all these coins, how many coins are left, children, now? Yes, we are left with only 1 coin. And what is the color of that coin, children? Yes, it is a green coin. And what actually a green coin represents? Yes, you are again correct, children. It is a negative number. That means we have only 1 green coin. This represents -1. That means -5 plus 4 is equal to -1. That means when I added a negative number, that is negative integer, and a positive integer, I got a negative integer, children, here, isn't it? Now, let us take another example here. I am going to add a positive integer and again a negative integer. So, first positive, then negative. So, let us add 5 plus -4. So, 5 represents, yes, 5 red coins because it is positive. Then -4 means it represents 4 green coins. Now, let us add them, children, as shown on your screen. So, I am taking these 5 red coins, and then below that I am going to place 4 green coins. Now, children, do you find again any 0 pairs over here also? Yes. How many are there like that? 1, 2, 3 and 4. So, that means here each 0 pair represents 0. We have already seen that, children, isn't it? So, that means these should be replaced with zeros. Then what is left? Yes, we are left with only a red coin. So, how many reds are there? Only 1 red, and red represents positive number. That means +1. That means 5 plus -4 is equal to 1. 1 means it is simply +1. So, generally for positive numbers we do not write plus before that number. Okay, children, 5 means it is understood that it is +5. 1 means it is understood that it is +1. Got it, children? And now here when I added 5 plus -4, that is a positive and a negative number, I got a positive number or a positive integer, isn't it, children? Whereas in the previous case I got a negative integer, and in this case I got a positive integer. Now, what do we conclude from this, children? So, I can write, when we add numbers of different sign, we first subtract the smaller number from the bigger number and give the sign of the bigger number. So, this is what we conclude from the above two examples, children. So, children, we have seen what actually an integer is, and also we have seen the addition of integers like two positive integers, two negative integers, and a negative and a positive integer, isn't it, children? I hope you have understood the concept of addition of integers. So, next we will move on to subtraction of integers, children. So, let us take an example, children. Let us subtract 4 from 5. So, here we have started with again two positive numbers, right, children. So, we take 5 minus 4. So, 5 it represents, yes, 5 red coins. Similarly, we have a positive number subtracted from another positive number, that is 4. So, from these 5 red coins we are going to subtract 4 red coins, that means we are going to remove 4 red coins. So, what happens? Yes, we are left with only 1 red coin. So, children, we have already seen red represents a positive number. So, since only 1 red coin is there, it means it is plus 1 or simply 1. That means we get 5 minus 4 is equal to 1. So, children, let us move on to our next one, that is subtracting a negative number from positive number, that is we are going to subtract minus 4 from 5, that is 5 minus of minus 4. So, 5 is again a positive. So, we take 5 red coins, then we have minus 4. So, we are going to take 4 0 pairs, children. Why? Because we do not have negative coins, okay? That is the reason we take 4 0 pairs. So, let us take 4 0 pairs, children, here. Why we take 4 0 pairs? Because 5 minus of we have minus 4. Since we have minus 4 subtracted from 5, we are taking 4 negative coins. Got it, children? So, since we are having minus 4, so we are going to take 4 0 pairs. Let us take 4 0 pairs, children, as shown. You can see 1, 2, 3 and 4. Now, out of these 4 0 pairs, now how many are there with green color here? 4, means 4 negative numbers, isn't it, children? So, each represents minus 1, then all those 4 represents, yes, minus 4. So, if I remove these 4 green coins, now what is left? Yes, absolutely right, children. We are left with 9 red coins. So, red coins represents a positive number. Since there are 9, so we write it as plus 9 or simply 9. So, that means 5 minus of minus 4 is equal to plus 9. So, this is how we subtract a negative number from positive number. I hope you understood, children, isn't it? Now, let us take another example, children. We are going to subtract 4 from minus 5. That means a positive number is subtracted from a negative number. So, minus 5 minus 4. So, minus 5 represents 5 green coins. From that, I am subtracting what? 4, a positive number. So, we do not have again 4 positive coins. So, what do we take, children? Just like in the previous case? Yes, we are going to take 4 what? 0 pairs, because we are subtracting 4, we are taking 4 0 pairs. So, let us take 4 0 pairs, children. So, 1, 2, 3 and 4. Now, out of these 4 0 pairs, and what are positive ones here? All red ones are positive ones. Now, since there are positive 4, we are subtracting. So, we remove all these 4 red coins. Now, once if we remove all these 4 red coins, we are left with only green coins. Now, count the number of green coins, children. Yes, they are 9. That means it represents minus 9. So, children, minus 5 minus 4 is equal to minus 9. Now, let us take one more example, that is when we subtract two negative numbers or negative integers. So, subtract minus 4 from minus 5. So, minus 5 minus of minus 4. So, minus 5 again represents 5 green coins, and minus 4 means again from that we simply remove 4, because we have 4 negative counters here, right. So, from that 4 is removed. Now, what is left? We are left with only 1 green coin. So, green represents negative number. So, since 1 green is there, it is nothing but minus 1. Okay, children. So, I can write it as minus 5 minus of minus 4 is equal to minus 1. So, children, till now we have done with addition of integers and also subtraction of integers. I hope you have understood the subtraction as well as the addition clearly. Now, let us move on to the properties of integers, children. So, let us take an example, children, as shown. Consider two integers 3 and 5. So, I have taken here both positive 3 and 5. Now, let us add 3 and 5. So, what do you get, children? 3 plus 5? Yes, we get 8. Now, what is 8? Yes, it is also an integer. That means, I have taken two integers, that is 3 and 5, and I added two integers 3 and 5. When I added these two integers, I got another integer. That means, I can say sum of two integers is also an integer, isn't it, children? Let us take one more example here. So, I will take a negative and a positive integer, that is minus 5 and 7 with the two integers. Now, let us add these two integers also, children, that is minus 5 plus 7. So, what do you get minus 5 plus 7, children? Yes, you get simply 2. How? We have already seen in addition of a negative and a positive integer. So, first subtract the numbers irrespective of their sign, subtract. The smaller one we need to subtract from bigger one, that is 7 minus 5, you get 2. Now, larger number has positive sign, so obviously the resultant number will get positive sign. So, it is plus 2. Okay, children. Now, when I added these two, that is a negative number and a positive number, that is a negative integer and a positive integer, that is two integers, you got back an integer again. So, I can say again sum of two integers is also an integer. So, from this what do you conclude, children? Whenever we add two integers, we get back another integer. So, I can say that closure property is satisfied under addition. So, children, we have seen examples of closure property. Now, let us see what actually the closure property is under addition. So, if a and b are any two integers and if a plus b is also an integer, then we can say that closure property is satisfied under addition in the set of integers. So, let us move on to another property, children. Now, before that we take an example. So, consider again two integers 6 and 7. So, let us add these 6 and 7, children. So, 6 plus 7, what do you get, children? Yes, 13, absolutely right. Now, let us add these numbers in other way, that is 7 plus 6. I am just changing the order of addition. So, first I have taken 6 plus 7, but now I have reversed the order 7 plus 6. Now, on adding 7 plus 6, what do you get, children? Yes, again you got the same integer, that is 13. Now, from these two, what do you conclude, children? Yes, I can write 7 plus 6 and 6 plus 7, both are equal, isn't it, children? Take a look at another example now. I will take a negative number and a positive number. Let us minus 5 and 9 with the two integers. Now, let us add them again, minus 5 plus 9, and adding these two you get plus 4. Now, let us add these two numbers in other way, children, that is 9 plus minus 5. So, 9 plus minus 5 is nothing but 9 minus 5, plus into minus, I write it as minus. Okay. Then what do you get, children? Yes, you got 4. So, here also I can say that minus 5 plus 9 equal to 9 plus minus 5. So, this is nothing but a commutative property under addition. So, we can say commutative property is satisfied under addition. So, children, we have seen examples of commutative property, isn't it, children? It is very simple and easy. Now, let us see what actually the property is. So, commutative property under addition states that if a and b are any two integers and if a plus b equal to b plus a, then we say that commutative property is satisfied under addition in the set of integers. So, now let us move on to another property, children. Let us take an example here. The first example, consider the integers 6, 9 and 5. So, I am taking here three integers 6, 9 and 5. So, let us add these integers as shown. So, first I am taking 6 plus 9 in bracket, that means what? First I am going to add these two integers 6 and 9, and with these two the next one. So, what do you get, children? Yes, 6 plus 9 is 15 plus 5. When I add these two again, I will get 20. Now, let us add the same three numbers in other way, that is 6 plus, now within brackets 9 and 5, which means I am going to add 9 and 5 first. So, 6 remains as it is, plus 9 plus 5 is 14. So, 6 plus 14 is 20. Now from this, what do you conclude, children? Yes, I can write 6 plus 9 within brackets plus 5 is equal to 6 plus 9 plus 5 in brackets. That means we can add integers in any order, children. Now this property is called associative property. So I can say associative property is satisfied under addition. So children, we have seen what is meant by associative property. So children, what I want you to do is you take or you pick any 3 integers and try the same property, okay, and see whether it satisfies or not, and definitely you will conclude that the property holds good for any 3 integers. Okay children, now let us see what the property is. Associative property under addition. If a, b and c are any 3 integers, and if a plus b within brackets plus c is equal to a plus of b plus c, then we can say that associative property is satisfied under addition in the set of integers. Let us move on to our next property, children, now. So let us consider an example here. So children, 9 plus what number or what integers gives back 9? Can you guess the number, children, here? Yes, you are absolutely right, children. It is 0. That means when we add 0 to 9, you get back 9. Let us take another example, children. Minus 5 plus which integer gives you again minus 5? Can you find out that integer, children? You are right once again, children. It is again a 0. Now let us take another example. So to which number if we add 9? So we don't know this number. To this we are adding 9 and you get the same answer, that is 9. Now can you guess this number, children, here? Yes, you are right. It is once again 0. So we get 0 plus 9 is 9. Let us take one more example, children, here. So to this number which is unknown to us, we are adding minus 5 and you should get back minus 5. Now what is this number or integer, children? You are right once again, children. It is again a 0. That means 0 plus minus 5 is equal to minus 5. Not only that, children, when I add 0 to 0, you will get back 0 only. So here 0 is called additive identity in the set of integers. Now let us define what actually an additive identity is. Okay children. So additive identity means if a plus 0 equal to 0 plus a equal to a for any integer a, then 0 is called additive identity in the set of integers. Let us move on to our next property, children. So before that, let us take an example here. So 9 plus which number gives you 0? Now this number is, yes, you are absolutely right. When I add minus 9 to plus 9, I get 0. Let us take another example, children, here. Minus 7, if we add which number, you are going to get 0. Yes, you are right, children. Once again, the answer is plus 7. That is minus 7 plus 7 gives you 0. Let us take one more example. Minus 9 plus which number gives you 0? So question mark, which number should be there? Yes, plus 9. That is minus 9 plus 9, that is plus 9 gives you 0. Let us take last example, that is 7 plus which number gives you 0? So here that number should be minus 7, that is 7 plus minus 7 equal to 0. So here children, if you notice, here when we are adding these two numbers, we are always getting the resultant as 0, isn't it? So here this minus 9 is called the additive inverse of 9. Similarly, this 9 is called additive inverse of minus 9. Likewise, I can say minus 7 is additive inverse of plus 7 and plus 7 is additive inverse of minus 7. So children, let us see what actually additive inverse states. Let us see children. If a plus of minus a is equal to minus a plus a, that is equal to 0 for any integer a, then minus a is called additive inverse of a. So children, you need to note one more important thing. We have seen minus a is called additive inverse of a, and also a is called the additive inverse of minus a. Okay. So for 3, minus 3 is the additive inverse, for minus 3, plus 3 is the additive inverse. So children, with this we have come to the end of our session, but before that, let us quickly recap what we have learnt in this session. The collection of positive numbers 0 and negative numbers is called integers. On the number line, numbers to the right side of 0 are always positive, whereas the numbers to the left side of 0 are always negative. Closure property is satisfied under addition in the set of integers. Similarly, commutative property is also satisfied under addition in the set of integers. Also, we have seen that associative property is also satisfied under addition, and also we have seen 0 is called the additive identity in the set of integers, and finally we have seen that minus a is called additive inverse of a and a is called additive inverse of minus a, where a is any integer. So, children, till now we have learnt what integers are, and also we have seen addition of integers, subtraction of integers, and also we have seen some of the properties such as closure property, commutative property, associative property, additive identity, and also additive inverse, isn't it, children? And we have seen few examples also of all these, additive inverse and additive identity, isn't it, children? Right. So, before we exactly conclude, I would like to give you few problems as assignment. You please do work out in your home and show to your teacher. Write any 5 positive integers. The second one is write any 5 negative integers. The third question is write the additive inverse of 10. Fourth question is if a equal to 2 and b is equal to 5, verify a plus b is equal to b plus a. The next question is if a is equal to 5, b is equal to 7 and c is equal to 9, verify a plus b plus c is equal to a plus of b plus c. Let us move on to a final question. Take any 2 integers of your choice and verify closure properties under addition for your integers. So, that is all for today, children. I hope you have understood all the concepts clearly. We will meet in our next mathematics digital class. Until then, goodbye, take care and happy learning.